Hi viewers, in today's video we'll start discussing about functions. We've been talking about function, trigonometric function. You'll be hearing so many things about function. So in this video, this is just a start on function. We'll be making so many things about function, but not on this very video. We will continue making different videos. So what is a function? Seeing the word function, you'll be thinking like an English student, you'll be like function, maybe it's just uses or maybe significance of something. But in mathematics, it's just when we say function, it's just a rule. Suppose I have two non-empty sets. Let's understand it diagrammatically. Let's say I have, let's call this A. Let me call this set B some kind of a cycle. I have a B. Sorry, cycle is small. I always have a problem with drawing. So we have two different, let's call this set A, let's call this set B. They are both non-empty. When I say non-empty, it means they all have elements in them, right? So even if I just write 0, 0 is an element. So this is a non-empty set. So these are two non-empty sets. Suppose I have element X, Y, Z in the A function, in the A set, and I have 1, 2, 3 in the B set. Recall I said they are both set. So I will call A, I will call it the domain. I will call B my co-domain. I'll tell you why. Now, talking about function. Function is a rule. Like when we say a rule, it means something that is just a regulation, something that you must obey. Function is a rule assigned to each element in A, a unique element in B. What do I mean by unique? When we say unique, it means just one. You can't pick more than two, right? So let's put this to practice. When we said a unique, every element in a unique element in B. That means if I have this, you see, A is mapped, X is mapped to 1, Y is mapped to 2, Z is mapped to 3. So you can see that each element in A have just one element in B. So assuming I have X to be mapped to this again, you see X did not pick just a unique element. X picked two different elements because X picked 1 and it also picked 2. So that means this is not a function right now. But the first one, which X, Y, and Z were picking just one element, is a function. So just to make a definition, normally mathematically we do write it as, we call the function f such that A is mapped to B. What I just did here is this. That is to say, the name of that rule is just, let me set an instance. Assuming they said everybody in, let's take a certain state. Let's say everybody should not go out in the night. That one is going to be like a night rule, or they call it curfew. That means that rule in which it restricts people from going out is called what? Curfew. So same thing with this. That rule assigned to each element in A to pick just one element in B is what we call F. So you see, F is a rule such that A is the one mapped to B. Had it been the English changed to F such that B is mapped to A, that means it is backward right now. Do you get? So what we said B mapped to A is different from A mapped to B. So domain is actually just like what is being ordered to pick something from the codomain. I don't know if you get. Sometimes the codomain, well, let's not jump to that first. So for instance, if I have, let's say, f of x, function of x, that means instead of f of a, let me say f of a. When I say f of a, it means f working on a. I don't know if you get. That is to say, that function working on a, for each element in A, I'm going to have just B. Like f of A is just going to be giving me B. So let me just take it f of x. Let me set one instance. If assuming, forget this for now, assuming I have a function f of x equals 2x plus 1. If I say, what is f of 2? When I say f of 2, it means, you see, x was here, I replace it with 2, right? So this is something as saying, anywhere I see x in the function, I'll be putting what? 2. So I'm going to have 2 times 2 plus 1. That is going to be 2 times 2, 4 plus 1, which is equals to 5. So you see, I inserted 2, I got 1 result. That is to say, this is a function. Had it been I put 2 and I get 2 results, then it is not a function, which is the same thing I was explaining here. For each element you insert into the function, you get 1 result. That made the function, that made that expression you had a function. So talking about the domain and the codomain, we'll still talk about it later on. So let's there are so many types of function, so many types. Let me just test your understanding. Assuming I have D and E, let's say it's just the name of the function is G, such that D is the one that is mapped to E. So now look at this. Tell me, is it true or not? I'm having X, Y, Z, 1, 2, 3. So I'm having this. Take a look at this. I'm still having, let's say, X and Y, another function. We'll talk about the result here. As I'm writing them, you should be thinking about your result. Like, what do you think is going to be? Is it a function or not? So I'm still having 1, 2, 3. So for this one, I'm having this to be this like this, then this, sorry, it should go here, it should be this. Let's just discuss about these two first before I bring additional examples. So is this a function? This is just a question you should understand. I said a function is a rule assigned to each element in the domain, a unique element in the codomain. So is this a function? X mapped to 1, Y mapped to 1, Z mapped to 1. Is this a function? Yes, it's a function. Do you know why? Because we said each element in the domain, just one element in B. That's what I said here, right? I did not say X, Y, and Z cannot pick one element. If they can pick just one, it's still unique element there. All of them are picking different things, right? So there are so many functions such that if you insert just like this type, if you put, let's say it's even, let's just say f of x, let me set one instance is x squared now. If I insert, let's say f of minus 1 is equals to what? What is f of 1? Let's look at this. F of minus 1 is same thing as just picking minus 1, inserting in x squared is going to be minus 1 squared. This is 1 squared. Minus 1 squared is 1. Minus 1 squared is 1. So you can see I inserted two different numbers, but I'm arriving at the same answer. So that means x and y might be different elements in A, but we yield the same result. So I have my x, y, and z pointing to one result. So this is a function. Yes. So how about this? I'm having x, y, z, x mapped to 1, y mapped to 2, and z mapped to 1. Is this a function? No, it's not a function because we said each element in the domain should choose just one element in the codomain. So look at this. I'm still having my z mapping to 1, x mapping to, sorry, I have a mistake. It shouldn't be like this. I'm supposed to put this. Very sorry about that. I'm having x mapped to 1, y mapped to 2, z mapped to 3 again. Z is mapped to 1 and mapped to 3 at the same time. It's not possible. I can't be here and still joining you. I can't be talking here and still watching myself from the camera. So that is not a function. So this failed. So that is how to understand a function. You just have to think very well, think critically, and observe. Is what you are given a function or not? Let's still take one more instance, a more complicated one. So suppose I'll just name this R, I would name this S. Suppose I have X, Y, Z. I have 1, 2, 3, 4. If I have something like this, is this a function? This is just a simple question. Is this a function? The answer is yes, it's a function. It's a function because I have X mapped to just one element, Y mapped to just one element, Z mapped to just one element, even though one element is left. So far, the element in R just picked one element from S. It's a function. So this is a function. So like I said, just all you need to do is to just calm down, look at the image, understand the definition, and everything will be fine. So one more definition of a function. A function is just a rule assigned to the element in the domain, a unique element in the codomain. So in our next video, I'll be talking about types of function and